All right. Hi, everyone. This is going to be my little virtual classroom for right now. I'm going to see if I can find more interesting places to move around because this is like the most boring spot in my house. But it's the easiest right now, and for sake of ease, we're just going to do it. So, before we get into the escape room activity, which I do anticipate being a little challenging only because it goes beyond can you just find the area, and then asks you an even deeper question. So some of you may have tried, and on that first page, maybe you said, oh, well, I know it's this many square inches of pizza, but I'm still not getting the answer right. So we'll talk about that second step, which is still, y'all still got this. I have faith in you, you got this. But before we get to that part, let's just review what we were doing before break, okay? So, my markers. So, one of the things we were doing before break was talking about the area of certain polygons, okay? So we had parallelograms, triangles, and trapezoids. Those were the three shapes that we need to know these formulas for, which, if you remember the word formula, really just is a recipe. It tells you how do you solve this. So the area of a rectangle is length times width. That's the recipe. You take the length, you take the width, you multiply them together, and you get your final outcome. Just like in a recipe, you take your ingredients, you put them together, you follow the instructions, and then you get this final product. Which, ironically enough, the word product means the answer to multiplication, which we're doing a lot of multiplication in these problems. So, then the next step was, once we've mastered triangles, trapezoids, and parallelograms, to say, well, now what if we have a weird shape, but that's made up of those? That's called a composite figure. So we'll talk about that after just the individual polygons themselves. So, area of a parallelogram, if you remember, back to, fourth grade, I think. A rectangle, right? Rectangles by definition have 90-degree or right angles in each of the four corners. But that is a parallelogram, right? We talked about two sets of parallel lines. Well, there's one set, there's another set. That is a parallelogram. And guess what? The formula we know for rectangles applies to all of the parallelograms. So that is like, whoop, whoop, whoop. This is going to be an easy one to remember because I've been practicing it since fourth grade, maybe even third grade. I've just never taught third grade, so I can't remember exactly when it's introduced, but I know for sure it's in fourth grade because I work in there and I see that they do it. So, when you have a parallelogram, again, definition, four sides, two sets of parallel lines. So, for example, let's say we had one set and then another set, okay? Now, you'll notice these don't have right angles in the corners. That's a special kind of parallelogram. But parallelograms just have to have the two parallel sides, and it's a parallelogram, right? Four sides and two sets of parallels. So, when we're looking at our parallelograms, it's very similar dimensions, like they're labeled in similar ways to our rectangle. So let's say, for example, this guy was 5 inches long and 3 inches tall. Okay? So this would be our length and width, right? And the area is length times width, which in this case would be, our length is 5, our width is 3, and remember, the beauty of multiplication, I could put the 3 first or the 5, doesn't matter, I get the same product, and then so therefore, my total area of this whole thing would be 15 square inches, right? So you gotta make sure that you include your units, right? Because that's really important. If it's centimeters, it's square centimeters. If it's feet, it's square feet. If it's miles, kilometers, whatever. Same thing over here. What if we had a parallelogram that was the same, right? I told you it was 5 inches across the bottom, and then I told you it was 3 inches tall. The height of that, how tall it is, was 3 inches. Well, guess what? And again, this is a review, so this isn't brand new, but the area of our parallelogram is still base times height. So even though we call them base, which typically just means bottom, and height means how tall is it, same thing with rectangles. Kids have always asked, well, which one's the length and which one's the width? That's the beauty, is it you can turn it on its side and it's going to have the same area, so really it doesn't matter. Similar thing here, base times height, you can put the 3 first or the 5 first, it's just multiplying two numbers together, so we can put them whichever way. So we could say the base of this guy was 5 inches, the height of it was 3, again I just multiplied them, so therefore my square inches would be 15. So I do this, you could do it either way. You just need to tell me that those are square inches and not straight inches, right? We're talking about a square, not just a line that is an inch long, okay? So, but exponents are like later in 6th grade, 7th grade, 8th, whatever. So if you just want to write SQ and then your unit, that's fine. That works for now. So, area parallelogram is simply base times height. Now the thing that I want you to remember, which I don't think on the escape room it happens, but in life and like state testing, which we're not doing this year, but in life and in textbooks and in all these other contexts, you might get something like this, where it's now telling you how long that angled side is. Guess what? I don't care, because I only need to know how long is the base and how tall is the shape. I don't need to know the side, okay? That's only when it's a rectangle, because guess what? The height is the same length as the side because it is very up and down. Parallelograms don't necessarily have square corners or right angles in the corner, so therefore they're kind of sloped or slanted a little bit. So the length of that will change as it tips. So we don't care about that. We still just need to know how tall is it from the base perpendicular straight up, okay? So right here from the base, from the 5 straight up to the other line that it's parallel with, and then that is the dimension that matters, is the height. So be real careful that you're not letting these extra dimensions confuse you, because that's kind of the way that the textbook companies or the test, whoever writes these tests, and they like want to see, how are you, if I just give you the 2, sure you can solve it, but are you comfortable enough with it to be able to ignore the parts that you know are not important or that you do not need it for this type of problem, okay? So make sure that you are remembering the crucial information and understanding and practicing like when it's okay to ignore information. So for the area of a parallelogram, our area is just the base, which is the bottom, by how tall is that shape, okay? Straight up from the base, perpendicular straight up to the other parallel line. That's the height that we want for this one, okay? So there's a review of the area of a parallelogram.